This is section 2.2, which is quadratic functions, and is connected to the AP Standard 1.3 quadratic rate of change. So we have two forms of a quadratic. We have standard form, which is f of x equals ax squared plus bx plus c. From that form, the only thing that's truly easy to see, you can tell if it opens up or down because of a is positive or negative. You can tell if it's a wider or a narrower parabola based on the a value. And the c is going to tell us what our y-intercept is. So vertex form is a little bit easier to see transformations. We have f of x equals a times x minus h squared plus k. Our vertex is h comma k. And we're going to look at this example down below, but just a reminder, to find your h value from standard form, you're going to use negative b over 2a. And then to find your k value, you're going to take f of negative b over 2a, or in other words, plug it into the formula to find out what the y value is. So if we look down here, we're putting this equation into vertex form. So I'm going to start by finding my h value, which is negative b over 2a. So remember, this is my a, this is my b, and my c. So I would take negative 12 over 2 times 3, which gives me negative 12 over 6, which is negative 2. And then to find my y value of my vertex, or my k value, we are going to find f of negative 2, which would be 3 times negative 2 squared plus 12 times negative 2 plus 11, and that gives us negative 1. So vertex would be at negative 2, negative 1. And so then it asks me to put it into vertex form. So if I'm going to write this in vertex form, I would take f of x equals, my a value stays the same, so it's still 3. Okay, it's going to be x minus h. So remember, this is my h and this is my k. So it'd be x plus 2 squared minus 1. So that would be my vertex form of that equation from standard form. One other thing about parabolas, the axis of symmetry. Just a reminder, our axis of symmetry is always x equals our h value. So in this case, it would be x equals negative 2. Okay. So the next one is, how do we find average rate of change from a quadratic? So we could graph it. So we could graph it and find the two values and then find the slope between those 2 points. But we also can find it algebraically. So remember, these are both x values when it's giving us an interval. So we can plug in those x values to find our y's. So if I can find f of negative 1, that would give me negative 1 squared minus 4 times negative 1 plus 5, and I get 10. And then f of 4, which is 4 squared minus 4 times 4 plus 5, which gives me 5. So these are both y values. So our change in our y values would be 5 minus 10 over 4 minus negative 1. So that would give us negative 5 over positive 5, which equals negative 1. So our average rate of change on that interval would be negative 1. Okay, our next example is to write an equation given the vertex of the parabola is at 3, 5, and it goes through the point 4, 9. So remember, our vertex is always our h and our k, and any point we ever have is an x and a y. So if we think about the equation, y equals a times x minus h squared plus k, we are going to fill in the values that we're given. So our y value is 9. We don't know a. Our x is 4. Our h is 3. And our k value is 5. So then we're just going to solve for a. So 9 equals 1 squared plus 5. So 1 squared is just 1. So this is 1a, or we could just say a. And so therefore a has to be 4. So we're writing the equation in vertex form would be y equals 4 times x minus 3 squared plus 5. If I wanted to put that into standard form, I could multiply out the x minus 3 times x minus 3, distribute that, then multiply the 4 into that, and then add the 5 to simplify. So the last part is talking about regression and residual plots. So I have the steps here listed for if you were using your TI-84. So just like with linear regression, you would go to Stat, Edit, and then enter your values, and then you could go over to Calc and find the quadratic regression, which is number 5. I also have the steps listed if you want to graph the residuals. So you can highlight the L3 value. So you can go up into list 3, have that highlighted, hit second stat, and then you should see in the menu it should come up as 7, which is residuals. And then you can plot list 1 and list 3 on a stat plot to see what the residuals are like. I'm going to show you probably a slightly easier way using Desmos. So that way we can look at the residual plot and the equation. So if I go to Desmos, I'm going to click the plus up there and add a table. And so my table values, I'm going to do 1, 3, 5, 7, 9. And then for my y values, I am doing 9, 12, 16, 25, and 34. Okay, so then I'm going to click that little scatter plot thing looking up by the number 1, and it gives me my options. So all of the regressions are in a list here. We want, for this one, we are looking at quadratic regression, so I'm going to switch to quadratic regression. You can see the r squared value is at 0.997. That gives me my A, my B, and my C values there. So you can see it's a little bit more user-friendly than having to go through the whole process of the TI-84, but both of them are options to find the regression. So then you'll see it says residuals and it says to plot. So I'm going to click plot. And if you look over here on my graph, the things we're looking for, always looking for with residuals, are that there's no clear pattern. So if it's a good fit, if the model is a good fit, there should be no clear pattern amongst the residuals. So if you look at that graph right there, all the dots are kind of hovering around 0, and we don't see a clear pattern. They don't look like they're in a straight line. They don't look like they're in a quadratic parabola shape. So we would say for this that a quadratic is a good fit. So that is how we can use regressions for quadratic functions.